we have already seen the different types of scaling we have available and how to implement them. Let's see what else we can do here. When we select the auto scaling group, we already know that in the Details tab, it shows us all the information about this auto scaling group. We have the Activity History tab where we see everything that has happened while working with auto scaling. In the Automatic Scaling tab is where we configure those scaling policies that we have already seen previously. On the Instance Management tab, we can do several things from here. For example, if I select my one instance that is currently serving my web page and I go Actions, and then Detach, I can disassociate this instance from the auto scaling group. Once the instance is disassociated, I can manage it independently from the rest of the auto scaling group. I cancel and re-enter actions and then configure and stand by. By doing this, I would remove the instance from the load balancer I have implemented, which in turn is associated with the auto scaling group. So, if, for example, I have two instances serving my web page and I configure this selected instance as in standby, the auto scaling group will no longer route traffic to this instance from the load balancer. There would only be one instance left in this case that would receive all the load. Why would I use this option? Well, I can put it on standby to upgrade or troubleshoot this instance. When I resolve it, we would come back here and put it back in service. I go to Cancel and begin Actions, and this time I enter Set Scale in Protection. When you enable this feature, it prevents instances from terminating during escalation events. This would be good if for some reason you want to get the logs for that instance before it is deleted. Another thing we can do here is to configure lifecycle hooks. Lifecycle hooks enable an auto-scaling group to take into account the lifecycle events of the auto-scaling instance, and then perform a custom action when the corresponding lifecycle event occurs. In the next class, we will talk in more detail about this feature. Also, we have this warn pool option. A warm pool or active pool is simply a group of pre-initialized EC2 instances. When there is an increase in traffic to the application, an auto-scaling group can be designed into the active group to meet the desired capacity increases. The purpose of an active group is to ensure that instances are ready to quickly start serving application traffic, thus speeding up the response to an upscaling event. For example, if you have a high-priority deployed system that cannot afford to go down and needs to meet user demand, you can configure this feature so that if at any given time an instance goes down or the auto-scaling group requests another instance to help with the workload, that instance is already pre-initialized and the response time to that demand is shortened. There are systems and applications that simply cannot go down, and if they do, they must recover in the shortest possible time. Therefore, I can choose here if those instances are going to be in stopped or running mode. If it's in run mode, keep in mind the costs because you will be charged for the runtime of those instances. Or you can leave it in stopped mode. This will do that. If one of these instances is needed, simply the instance starts and starts serving traffic. It is not the same for auto-scaling to add a new instance as it is to simply call this one and just start it, since you have to take into account the time it takes for an instance to be created, started, and pass status checks. So, I can tell it here 3 instances or choose below to have pre-initialized the number of instances allowed as the maximum capacity configured in my auto-scaling group. If the maximum number configured is 4, it is only 4 that will be ready. When you do that, you will see it here in the warn pool section. Now, in the Monitoring tab, we can see a collection of metrics for both auto-scaling and EC2 instances. If it is auto-scaling, we can see all the metrics that are included here. If it's EC2, you would see the metrics related to the EC2 instances that are part of the auto-scaling group. And you can add all of this to a CloudWatch dashboard. Finally, we have the Instance Refresh tab. With this, you can use an instance refresh to update the instances in your auto-scaling group instead of manually replacing instances a few at a time. This can be useful when a configuration change requires you to replace instances and you have a large number of instances in your auto-scaling group. When might you normally use it? when you have a new AMI or a new user data script. So the first step would be create a new launch template that specifies the new AMI or user data script. And then I start the instance refresh to start updating the instances in the group immediately. This will EC2 Auto Scaling. Grab that new template with the new AMI or the new script, start applying it to the instances, and when they are ready, they are added to this auto scaling group. Now, as we are solution architects, we should know that this replacement of instances by the new ones already updated, we cannot do it all at once. We must do it gradually. So, if I have 6 running instances that are serving my website, I can set the percentage to 80 or 90%. If I set it to 100%, this will do that. The replacement will be 1 instance at a time. If I set it to 0, all the instances will be replaced at the same time, which we probably don't want if this is all in production and in constant use. Unless, of course, it does it when it is not in use. If it is, for example, at 90%, it would replace 2 or 3 instances at a time, leaving the other remaining instances serving my website traffic. Once the percentage is set, I would just click Start and begin the upgrade process. So, these would be some advanced settings we have in EC2 Auto Scaling.